Question number 15. We have a moving object, which is a bullet. Glitch here. Remember, we need kilograms. This is in grams. They're tricky. So a moving object, we're given both mass and speed. So that's easy. We can figure out kinetic energy. And then it says penetrates a tree trunk to depth of, and we need to use work and energy considerations to find the average frictional force that stops the bullet. Work energy, net work, equals change in K. It stops the bullet. Therefore, my change in K is 0, because my final kinetic energy is 0, minus mv initial squared over 2. So that will give me by how much energy changed. It will be a negative mv initial squared over 2. Assuming the frictional force is constant, determine how much time elapses between the moment. So first, I need to figure out the average frictional force to begin with, the force itself. So work net is the work of friction, and it will be force of friction times this distance of 5.5 centimeters. Remember, it needs to be meters. And then cosine of 180 degrees. Why 180? Because if the bullet is going to the right, friction is to the left. So the angle between them is 180 degrees, which cosine of 180 is just minus. So I can say negative force of friction times d. Well then, because work net equals change in kinetic energy, and that is change in kinetic energy, and that is my net work, I can just say force of friction times d equals mv initial squared over 2. And then force of friction itself is going to be mv initial squared over 2 distances. Then we have our mass of 780. So 7.8, 10 to the negative third, because it has to be in kilograms. 575 squared. So force of friction is 2.42 times 10 to the fourth newtons. Assuming the frictional force is constant, determine how much time elapses between the moment the bullet enters the tree and the moment it stops moving. You will later find a shorter way to solve this, but for now, if I know my force of friction as net force, then I can find acceleration as 2.42 times 10 to the positive fourth, divided by mass, which is 7.8, 10 to the negative third. And then formula for acceleration, as you remember, is v final minus v initial to the time that passed. 0 minus 575 over negative 3. And then that's times 10 to the negative 6. So 1.92 10 to the negative fourth seconds.